Okay, so as we begin today, we will finally finish up the rest of this chapter, which um, we still got a little ways to go on account of what this last slide will say here shortly. Okay, so the importance of Roman numerals is what? Right. So these Roman numerals will tell you the charge of that atom. All right. Okay, now, when we're referring to these, like for instance, tin here, when it just says plus 4, is that a monoatomic ion, or do you think it's possibly a polyatomic ion because there's two different charges? You would think so, but that's not the case because it's still only one element forming one distinct charge. It's these, then, that are the polyatomic ions. Okay? So it's when more than one element forms an ion, because here, again, it's just one element forming an ion here, whether it's plus 2 or plus 4. All right? And we'll illustrate how these atoms form, or excuse me, these ions are formed from these molecules, if you want to call it that. And through practice, you will be becoming better at remembering the names of these ions, and then ultimately the charges then as well. To me, I've always looked at perhaps the first time you see this, maybe the hydroxide ion might be maybe the most difficult to try to remember when you look at a formula. Notice when you see sulfate, for instance, we know what elements are going to be in there then, according to the formula. When you look at sulfate, we know what element's going to be in there. Sulfur. So if we're looking at phosphate, then we know it would be which, phosphorus. Okay. So that's why I say maybe hydroxide could be an exception, unless you look at the hydro part, meaning the hydrogen portion with this. And it's really important to get that concept down of what a least common multiple is, especially when these charges don't add up to 0. Okay, does everyone have this information that wants it? Okay, so, well, that does it for this for the most part. Let's go ahead and do some examples of these, because I see we've got a paper that's going to be assigned. For some reason it says the 22nd. I don't know why it says that. It should probably be the 25th. So with that, let's get rid of this and do some of these examples. Okay. All right, so let's we'll keep it, well, I'm not saying we're keeping it simple. Maybe none of this is simple. So we'll start with aluminum. And hydroxide, nitrate, carbonate, or sulfate. Okay? Because we talked about POP yesterday. Okay. Fair enough. Okay, so if we encounter this formula, or excuse me, this name, we know what's the symbol for aluminum. And then what we just wrapped up, the formula for the carbonate ion is CO what? Okay? So upon doing that, now we've got our aluminum carbonate on there. And the next thing we need to do is put our charges in here. So the charge for carbonate is negative what? Charge for aluminum is plus what? Okay, and we've never encountered anything like this before. It's either been a 3 and a 1 or 2 and a 1 or something to that effect. Now we see a 3 and a 2. So those charges don't add up to 0. What is your least common multiple between 2 and 3? And it is 6. Okay? If you use 2 or 3, that's your least common divisor, I believe. That's the smallest number. That's more of a mathematical term, but you want the smallest number that these both divide into. If you were to pick 3, I mean, you're fine there, but then you have 1.5 molecules of carbonate. That won't work. Or if you put a 2 here, well, then that's fine. That works all right for carbonate, but then you have 2/3 of a charge for aluminum, and that don't work. So that's why we pick 6, and when you divide them into each other, what happens? The answer you get tells you what? The number of atoms in that formula. So 6 divided by 3, the answer you get, you need to put down here. Okay? Now, this is one carbonate ion, CO3. But, according to this, we don't want just one carbonate ion. We want how many? We want 3 of them. Okay? So upon doing that, 6 divided by 2 gives us 3. So if we put this down here, how could that be misleading? You're saying you got 33 oxygens. I think even common sense would say that that's not correct. So if this was one carbonate ion, we wanted 3, we would put this formula inside of what? There we go. That's how you would write aluminum carbonate. Okay? So very quickly, to see how this forms a -2 charge, just think of it this way. Okay? We know that oxygen has a charge of negative what? Just the oxygen now. -2. Okay? So that's how many total charges then? Negative what? -6. Okay? Because when you multiply, we're not adding, when you multiply these two, so for every oxygen atom, there's a -2 charge. We've got 3 of them, so that's -6. Now, carbon being in the 4th column is going to have a plus what charge? 4. Okay? So, remember, 3 times 2 is -6 for these oxygens now. So if you add 4 to a -6, what would you get? And what are we supposed to get? -2. What is an ion? You don't want 0. Okay? So in a compound, you want these to add up to 0, but an ion is going to give you either positive or a negative overall charge. This is a lot of, it doesn't look like it's a lot of information, but it is, and it's very important to try to grasp that the first time. If you don't catch it the first time, you get it the second time. Maybe for basketball, about what time in years do you think, let's say you're in second grade, whether it's you ladies or gentlemen, second grade, or even volleyball, but we're going to use basketball because I'm more familiar with that. At about what year in schooling would it be you're standing at the free throw line, you no longer have to jump anymore? Because it used to be, maybe you're in third grade, you probably couldn't just stand in one spot and shoot. You just didn't quite have the muscles to do that. It's not that you were weak, but you just didn't have the muscles to shoot that 15 feet. Okay? So maybe for you gentlemen, maybe 6th grade, may be about the time you can just stand in one spot and shoot. Ladies, maybe 6th grade, maybe it was 7th. Maybe yes, maybe no. Okay? But upon doing that, you might not have got it that first time, might not have been successful that second time. It's just one of the things you want to keep at it. Same thing with volleyball when you're serving. Just think of that first time where maybe you were playing volleyball, you had to underhand it like this, and thought, well, I'm going to try this overhand deal. Goes 10 feet. Next time it goes 12 feet. I don't even know how far is it from the back line to the net. It's like 20? That seems like a logical number, don't it? Okay. So just think of how much practice it may have taken to finally get that ball over the net. Okay. It doesn't mean you're bad at it. Just might mean you might have to put a little more work into it. So that's why this atom or this ion has a charge of -2. All right. So left middle. Are we good with this? Okay. Middle. We're not playing peekaboo. Okay. And right outside. Right outside. Okay, right middle. Left outside. Okay, so more examples. There's nothing wrong with that. Okay, perhaps we can do something, we'll say a little easier. How about, it might not look like it, but how about this? Copper to carbonate. If you really have a good understanding of this, which some of you have indicated you do, does this look like this would be a really difficult formula to write out? You're shaking your head no already. Okay? Now, some people might be thinking, how can they know that? Well, that's why you have some people who serve the ball, some people who set the, I can say spike or whatever, or some set. That's why some people play on the line, some people are backs, some people are on the defensive side of the ball, some people are on the offensive side of the ball. That's why some people play the drums, some people are brass instruments, and some people are woodwinds. Did I miss anything in the band? Brass, woodwinds, percussion. Is there something else in there? Is there anything that some of you have never heard of before that aren't in the band? Woodwinds are what? Clarinets, saxophones, and flutes. I suppose you say oboes and anything that has a reed to it. Does that sound right? Then flutes don't have reeds. How can they be a woodwind? Maybe they were at one time. Could be. So then your percussionists are, of course, bass drum, snare drum, tritoms, quads, all those. Okay, anyway, enough of that. So this looks like it might be difficult, but it's not. Okay, what's the symbol for copper? Okay, what's the form of this carbonate ion? We just wrote it. always go by your negative ions first. Carbonate has a charge of negative, okay? And copper can have two different charges. Well, this Roman numeral here isn't for looks. So copper has a what charge then? Positive 2 in this case. So, do those charges add up to 0? They do. So, do we need to change anything in here? Then the answer would be no. Okay? The idea is to get them charges to add up to 0, and sometimes you will have to put subscripts down there. Okay? So, in aluminum carbonate's formula, which one is the monoatomic ion? You're right. Why are you right? Not all, well, that's true. But how many elements make up aluminum's charge? 1. How many elements make up carbonate's charge? 2 different, carbon and oxygen. So that's why it's a polyatomic ion. Okay? Hopefully we're a little more clear. We won't see if we're checked for understanding yet. All right, so can I erase? Well, we're going to come back to this in just a moment because we want to add together atomic masses. Okay, so, So someone go ahead and pick an element between 21 and 30. Okay, so we've got some zinc, and someone give me a polyatomic ion. So sulfate, carbonate, phosphate, hydroxide. That's what we want, okay? So now as we look at this, the symbol for zinc is what? That's the charge, yep. Okay, the hydroxide ion is O. 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 22. Deuces. Isn't that? You don't do. He, not T. Yeah. No one does deuce. You don't do this anymore? Or is it just deuces? That's not. Okay. Well, we'll keep going. All right. So go by the charge. Your negative ion. Hydroxide has a charge of, I heard it earlier, negative what? Okay? Zinc has a charge of plus what? Now, I don't expect you to do this without your periodic table. Don't be sitting there thinking, gosh, I got to remember all this. No. Wipe that from your thoughts. I don't expect you to have this memorized. Okay? We want you to know how to use this. So, do these charges add up to 0? No. What's the least common multiple? Between 1 and 2. Okay? So, don't feel that, gosh, I shouldn't have to do this anymore. Okay? Well, should someone be asking you a question, and if it looks right and it's not, you're going to look back and say, well, that looks like it's right. Well, you're not going to be helping anybody out. Okay. So 2 divided by 2 gives you what? 1. And this OH is 1 hydroxide ion, but we don't want just 1. We want what? We want 2 of this whole ion. So in order to do that, you would put it in parentheses like that. Now we've got that to add up to 0. Okay. Now the last thing we're going to do We're going to add up some of these atomic masses. Okay. So we're going to start with the simplest of these first, then move forward. So, of these three formulas, the zinc hydroxide, the copper 2 carbonate, or the aluminum sulfate or carbonate, which one do you think would be the easiest to add up the atomic masses? I would say not, but we're trying. That's what we ask. You are right. Why is that? Right. Because you don't have any parentheses there. That's the main concept. Okay. So, with this then, the atomic mass of copper is what? Okay. The atomic mass of one carbon is what? And the atomic mass of one oxygen is what? 16. Now, would you rather write 16 down here 3 times, or would you rather write 48? Okay. Now, keep in mind what this is saying. One oxygen atom is 16, and we've got 3 of them. So if you take that, you would get 48. That's where that number's coming from. So you can write 16 here 3 times, or you can just multiply it like that and put that here. Okay, so 0.55, 10. I did that really fast. Is that right? 123? 10, 13, 1, 7, 8, 12. Yep, that's right. We're going to do just one more example. So, looks like a colon here. Okay? Yeah, I think that's right for copper. Yeah, but this is accurate enough. Okay? So, next one. You want to do zinc or aluminum? The zinc, that would be the easier of the two. Okay. So, over here, what's the atomic mass of zinc? Okay? And this is where it gets to be a little tricky, because what do you suppose you have to do with this 2 since it's on the outside of the parentheses? You have to distribute that. You'd have to do the same thing here if we were doing that one. But in this case, oxygen has a mass of what again? 16, but how many of them do we have? So 16 times 2 is 32. Okay, one hydrogen is 1.01, and how many of them do we have? So that's 2 point. Okay. Yep. Okay, 99.41. Yeah. So keep in mind that doesn't pertain to the zinc here. Okay. All right. So notice these concepts continually build upon one another, and especially when we get to next chapter and we're balancing chemical reactions, we want to make sure that we can actually understand this. So, middle, are we good? Okay. Right outside. Right outside. Okay. So left middle. Okay. Right middle. and left outside. Okay, so this is going to be a slow process. Don't think that, oh my gosh, we're going to just go over just these few examples and we're going to have to work on this tomorrow. No, that's not what we're getting at. Okay, so that's all I've got for today. So we'll catch up to you next time.